Ilakasan ko yung sound. Yan. Ngayon.
Bernoulli's principle.
Okay na?
The flow of a fluid is streamlined if
Meron ng
every
sound?
particle of the fluid
Apo, sir.
follows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of liquid entering per second at A1 and mass of liquid leaving per second at A2. Assuming there is no loss of fluid in tube, that each for ideal fluid therefore, or AV equals constant. This is the equation of continuity. When fluid flowing through a section of pipe with one end having a smaller cross-sectional area than the pipe at the other end. The velocity of the fluid in the constricted end must be greater than the velocity at the larger end. Bernoulli's equation applies conservation of energy to formalize this observation. Consider a tube AB of varying cross-section A1 and A2 and at different heights H1 and H2. Liquid is flowing from A to B. P1 is greater than P2. Here, A1 is greater than A2. So, V1 is less than V2. The force on the liquid at A and at B. Now, the work done per second on the liquid at section A and at section B. V1 equals V2 equals V. Equation of continuity. Net work done equals P1V minus P2V. The net work done per second is equals increases the potential energy and kinetic energy per second from A to B, according to law of conservation of energy. Bernoulli's principle.
Ulitin natin ha, isa pa ha.
The flow of a fluid is streamlined if every particle of the fluid flows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of liquid entering per second at A1 and mass of liquid leaving per second at A2. Assuming there is no loss of fluid in tube, that each for ideal fluid therefore, or AV equals constant. This is the equation of continuity. when fluid flowing through a section of pipe with one end having a smaller cross-sectional area than the pipe at the other end. The velocity of the fluid in the constricted end must be greater than the velocity at the larger end. Bernoulli's equation applies conservation of energy to formalize this observation. Consider a tube AB of varying cross-section A1 and A2 and at different heights H1 and H2. Liquid is flowing from A to B. P1 is greater than P2. Here, A1 is greater than A2. So, V1 is less than V2. The force on the liquid at A and at B. Now, the work done per second on the liquid at section A and at section B. V1 equals V2 equals V. Equation of continuity. Net work done equals P1V minus P2V. The net work done per second is equals increases the potential energy and kinetic energy per second from A to B, according to law of conservation of energy. Bernoulli's principle. The flow of a fluid is streamlined if every particle of the fluid flows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore,
So, kunin lang natin yung sa video, kunin lang capture ko lang so that we can have kind of point of discussion, no? Habang inaano ko rin yung mga PowerPoint. May ready na tayong
Bernoulli's
PowerPoint.
principle.
Sorry. I-capture ko lang dito para makapagsulat ako sa digital pad, ha? Kasi hindi natin ma-discuss pag hindi nakalagay sa Pag hindi nakalagay sa PowerPoint. Bernoulli's principle. Tama ba to? Bernoulli's principle, no? So, yan, no? So, i-capture ko lang yung mga nasaan na ba tayo? Yung mga nasa video, no? Sige.
The flow of a fluid is streamlined if every particle of the fluid flows exactly the path of its preceding particle and has the same velocity as that of its preceding particle. Consider a fluid moves through a tube of area of cross-section A1 and A2 respectively. The volume of water entering A1 per second and the volume of water leaving A2 per second. Therefore, mass of liquid entering per second at A1 and mass of liquid leaving per second at A2. Assuming there is no loss of fluid in tube, that each for ideal fluid. Therefore, or AV equals constant. This is the equation of continuity. When fluid flowing through a section of pipe with one end having a smaller cross-sectional area than the pipe at the other end, the velocity of the fluid in the constricted end must be greater than the velocity at the larger end. Bernoulli's equation applies conservation of energy to formalize this observation. Consider a tube AB of varying cross-section A1 and A2 and at different heights H1 and H2. Liquid is flowing from A to B. P1 is greater than P2. Here, A1 is greater than A2. So, V1 is less than V2. The force on the liquid at A and at B. At A, force on the liquid at 2. The force on the liquid less than V2. The force on the liquid at A and at B. Now, the work done per second on the liquid at section A and at section B. V1 equals V2 equals V. Equation of continuity. Net work done equals P1V minus P2V. The net work done P2V. The net work minus equals P1V minus P2V. The net work done per second is equals increases the potential energy and kinetic energy per second from A to B. According to law of conservation of energy,
Tapos na ba to? Tapos na, no? O, sige.
Bernoulli's principle.
Okay. So, we're going to discuss the video, no? So, para magkaroon tayo ng learning and insights, no? Kaysa naman panoorin lang natin ng basta-basta ng hindi dinidiscuss, no? So, now, our topic, nadidinig ba, class? Okay na? Hello? Hello, class. Maliwanag ba? Nakikita yung screen?
Yes po.
Okay. So our topic for today, as requested ng class, no? So instead of having the presentation or recitation for the fluid statics and properties of fluids, we are going to discuss the Bernoulli's principle and the so-called continuity equation. Now, ito yun. What is continuity? Continuity equation, let me write yan, no? Okay, I'll change the color, no? So that I can write with my digital pad, no? So continuity equation, when we talk about continuity equation in fluid mechanics, it is It can be summarized with the following formula. Now, Q equals A times V. Q, let us define Q is what? Discharge flow rate, no? Discharge flow. Ibig sabihin yan, meter cube per second or cubic feet per minute, di ba? Or liter, sa iba, metric din, pero pag liquid kasi liter eh. Liter per minute, no? Or L, ganyan, liter per minute, no? LPM. So, huwag kayong malilito. Don't be confused because, there are a lot of notations being used as far as expressing the units is concerned. No? LPM, liter per minute, pwede ring liter upon minute. No? Cubic feet per minute, tinatawag to na CFM. No? Cubic feet per minute. Wala nang per, walang P. No? CFM lang, cubic feet per minute. No? So whether it is air, an amount of air per unit time or liquid, no, like wet, basa, no, CFM 'yon, no. In metric, meter cube per second, no. Malaki to malaki yung meter cube kasi isang metro, 'di ba? Tapos ganyan, 1 meter yung width, tas yung length 1 meter, tapos yung height is 1 meter. So meter cube is very large for an air, no, or for any, even for liquid, no, malaki yan, no. So pwede ring centimeter, pwede mong pababain centimeter cube, di ba? Per minute, no, and so on. Now, if we're going to check the units, area is like for metric square meter, and then velocity is meter per second. So if you're going to multiply the two, so meter square and meter, you will have meter cube, and then this one is second, no? So yan ang unit ng Q. Okay? So ito yung unit ng Q. The volume of fluid, whether air or liquid like water, that pass a certain area or space per unit time, 'di ba? So amount of fluid, so meter cube, no, or liter, that pass certain uh, or flow, no, that flows in a certain tube or a certain conduit per unit time. Okay? So, anong ibig sabihin niyan? We can explain that continuity equation according to Bernoulli. Ang ibig sabihin lang naman niyan ay law of conservation of energy, no? So, ibig sabihin, yung energy cannot be destroyed or cannot be created, no? Or law of conservation of mass. Ibig sabihin, it means that yung mass in equals mass out. Halimbawa, nagbuhos ka ng 1 litro, 'di ba? Nagbuhos ka ng 1 litro mula dito papunta ron, no? Oh. Ibig sabihin, kung ano yung binuhos mo na mass, yun din ang lalabas, 'di ba? Alam namang maiwan doon yung iba, no? So, mass in equals mass out. Okay? So, yun lang ang ibig sabihin yun per unit time, no? Ngayon, pag kukunin mo yung volume, eto na rin yun, no? Yung area times velocity, it will give you the flow rate, no? Kung ano yung binuhos mo dito, ibig sabihin yung Q, no? Let me let me use the white one, no? Kung yung discharge Q1, for example, if you're talking about point 1 here, and this is the point 2, Q1 equals Q2. Ano ibig sabihin? If you are going to break down the formula, A1, area 1, velocity 1 equals area 2, velocity 2. No, ganun lang 'yon, no? Now, it depends on the liquid. If it's water, for example, if it's water, so density and density of water, maka-cancel naman 'yan, di ba? Kasi isa lang 'yan eh. Di ba? So whatever appears on the left is also appearing on the right. So kung tubig 'yan, edi cancel lang. No, kung langis, di cancel, no? Hindi naman pwedeng yung tubig naging langis, no? So that means yung tinatawag na homogeneity, no? Homogeneous, no? Siyempre pa nagbuhos ka, isa lang naman yung liquid, di ba? So even if you put density, no, pag minanipulate mo na yan, maka-cancel. For example, if you put the density or rho here, di ba maka-cancel, no? Yan, maka-cancel, di ba? So magiging A1 V1 A2 V2, no? So what is this called? What is the equation called? No, it is called by the name continuity equation, no? So in fluid mechanics, if you are asked about what is the continuity equation, or area times velocity, as easy as that. Now, there's another insight here when we talk about the area, no? So tingnan niyo yung area. Look at the area. This area and this area is not the same because this one is bigger, no? Bigger, and this one is smaller. Now, how do we interpret this? So maalala nyo, for example, if you are watering a garden, in the garden, no? So di ba may hose ka diyan, may hose, no? Tapos sa dulo ng hose, may tinatawag na adjustment, no? Pwedeng adjust. You can roll with your finger, no? So ito yung tinatawag na nozzle. Now, in general, it is nozzle, but in engineering term, we call that, for example, venturi or orifice, no? Pag nagbago kasi ng diameter mula sa malaki, no? If you have a bigger diameter, then it becomes small. Dun ka na, papasok ka na sa orifice or venturi, no? Tao to na Italian physicist, Venturi meter. So all these are almost synonymous, meaning they are almost the same. Venturi meter, orifice, and in general, nozzle. No? So naintindihan ba yung sa garden? Pag nag-garden kayo, di ba? If you adjust the diameter of the nozzle, what will happen? If the diameter becomes small, then there's a jet, na parang jet of water, bibilis. The water becomes faster. Why? Because the area concerned, no, become small. So from this area to this area, no, naging maliit. So the restriction in area makes it produce a jet of water, meaning mabilis. Yan, no? Yan ang ating pag-uusapan. So here is the summary of the continuity equation, no? As I explained a while ago, area 1, velocity 1, area 2, velocity 2. But the density of 1, point 1, di ba kung tubig yan, tubig rin naman to, di ba? So if this water, this is also water, so pareho lang yan, maka-cancel yan, no? Anything, no? But the area is not the same, no? So this one is bigger and this one is smaller. So, hindi mo siya maka-cancel. Then, velocity 1 and velocity 2 is different. Ngayon, ang tanong, ano ang nangyayari sa velocity? Yun ang magandang tanong. Sa area, it's pretty much obvious that this area is bigger, no? By our naked eye, and this one is smaller. Now, what is happening to velocity, no? So ang sagot, the answer is the velocity is here, no? Becomes faster, meaning increase, no? Faster means velocity is kind of it's a vector quantity because it has a direction, no? May direction na yan. Speed is kind of scalar, no? When you talk about velocity it's a vector, no? May quantity, may magnitude and direction. Ibig sabihin may quantity and then to the right, to the left, or kung anumang angle. Okay? Now, what happens to the velocity in point 1 and point 2? So, ang sagot natin, the velocity at point 2 is greater than point 1. No, bumilis, no? Bumilis. No, yun yung talagang nangyayari. Now, what is our insight when it comes to certain datum. Pag meron ng pag meron ng distance, kasi kanina 'di ba diretso lang? A while ago, it's just straight, streamlined and straight. So no datum, no height. Ngayon, if we are talking about fluid and we have a kind of reference, no? Reference dito. Yan. Ang reference natin, no? So meron na siyang head, no? Ang tawag dito ay head, no? Head or height. Sa fluid mechanics, ang height o yung taas, ang tawag ay head or energy head kasi may energy yan eh, no? Yung energy niya ay inequate sa isang linear, no, linear. So eto magiging meter or feet, no? So pwede yung meter or feet kasi linear nga yan, di ba? Linear. Sinusukat mo yan ng ano, ng isang dimension, ng isang degree lang, no? Hindi naman yan area ng square. So, mahalaga yan. That is important. For example, if you are computing how much horsepower to be used in delivering a fluid in the building. So the building is high, like third floor, fourth floor, 10th floor, or even 100th floor. For example, in Dubai, where the highest building is located, no? What is that pump na magdudul magpa mag mag ano mag deliver ng fluid, no? If you are getting my point, this the building, building yan, no? Oh, siyempre yung pump mo, 'di ba? May motor, 'di ba? Motor muna bago pump, 'di ba? Bago pump. Kasi yung motor papaganahin niya yung pump di-deliver niya yung fluid mula sa baba pataas, no? So, ang tawag dito, yung ika-counteract niya na height ay head, no? Total Dynamic Head, TDH. May formula dyan, no? So, Total Dynamic Head, no? If I may write, Total Dynamic Head, head, no? Energy Head, TDH. Okay? So, now, eto, I just want to point out, no? Eto yan, um, there's a height and there's a height here. Also, there's a difference, no, in height. A while ago, we were able to discuss what's happening in the what do you call that? In the velocity. We understood, no, we were able to synthesize and to to analyze that velocity one is what less, no, than velocity 2. Meaning, velocity 2 is greater than velocity 1 kasi lumiit yung area, no? Lumiit yung diameter, liliit din yung area, no? Yan. So now, the second insight is about this pressure. Anong masabi mo sa pressure? Pressure 1 daw, no? So ito, look at this. So pressure 1, if I may rewrite here in this space. So pressure 1 is greater than pressure 2, no? May isa pa diyan eh, may tatlo kasi yan eh, no? So if you have discharge, then if you have a kind of area is pretty much obvious, no? Mas malaki to. Area, ano pa isa? Velocity, pressure, no? So, ang mahalaga diyan yung discharge ay equal, area mas malaki, velocity ano mas maliit compared sa point 2, and yung pressure nga ay nag-drop, no? So pressure 1, if I may continue, is greater than pressure 2, no? So hatiin mo 'yan. Ngayon, velocity 1, anong nangyari? Is less, no, than velocity 2, no? Kasi nga ano eh, mas bumilis dito kasi maliit yung ano nagkaroon ng jet, no? Area is pretty much obvious. Of course, area is greater in point 1 than in point 2. What about Q? Ano nga yung Q? Ano nangyari sa Q? Equal. No? Kasi nga, continuity equation, whatever you put in, that is also the one coming out. No? Whatever you put in, na amount of liquid, tapong ka ng isang balde na pinadaan mo sa tubo, o isang balde rin yung lalabas. Di ba? Ganun lang yon, no? So, eto yon, no? So, maliwanag, in terms of pressure, pressure 1 is higher than pressure 2. Bakit? Ito yung paliwanag. Kasi etong dalawa ay may kaugnayan sa energy, no? Yung isa ay potential, yung isa ay kinetic. Ano naman yung potential at kinetic? Let me use this, no? So yung potential energy, no, we always hear about potential energy, pero kung minsan hindi natin na-absorb kung anong meaning, no? Pag sinabing potential energy class, it is an energy based on position, no? Or elevation, no? Elevation. Pero in general, position nga, no? Position, no? Ang kinetic, ano yan? Di ba alam natin sa elementary, kinetic energy is energy in, ano to? Motion, no? So energy in motion, kinetic. So ano nangyari dito? Ang nangyari dito, class, no? Dito muna tayo sa state. Ang nangyari dito, yung pressure, malaki yan, di ba? Yung pressure. Dito, nag-drop yung pressure, no? So going down, when the pressure goes down, what happens to speed? Velocity goes up. Ulitin ko, no? So this has a pressure where as the diameter is constricted or getting smaller, so in this point, ang liit na ng diameter becomes small, no? Small diameter, ang nangyari, the pressure drop because the velocity goes up. Meaning, the velocity becomes higher, no? So yung part of potential was converted to kinetic, no? So yung potential natin was converted to kinetic due to the constriction or size of the diameter, no? Sa pag niliitan mo ang uh, butas or diameter, biglang bibili, sisirit, no? Why? Because it was converted to kinetic energy. So ibig sabihin, yung energy was kind of transformed, no? Na-transform lang, no? Hindi nawala. Yung pagbagsak niya ng pressure, napunta pala doon sa velocity. Bumilis yung velocity kasi nga lumiit yung diameter. Nakukuha ba? Yung a loss, no? Energy loss at one side is energy gain on the other side, no? So energy in, energy out. So yun yung ibig sabihin ng tinatawag na law of conservation of energy. Kung ano yung nakuha sa isa, galing yun sa pagkawala sa kabila. O yung na-absorb ng isang side, galing yun sa source, no? So, ganun lang ang ibig sabihin ng law of conservation of energy. Now, we continue. Maliwanag na to, ha? Anong mangyayari? What happens to the velocity? The velocity goes faster from bigger to smaller diameter. What happens to pressure? The pressure drops, becomes smaller from higher or bigger diameter to smaller diameter. Okay? What happens to discharge or volume flow rate? It retains, no? It maintains the same amount, no? Q1 equals Q2. Area 1, V1, area 2, V2. Yung area mo, this is higher or bigger, is smaller. Velocity 1 is higher, is smaller than velocity 2. Kasi bumilis nga dito, no? So, velocity 2 is higher. So, nababalance, no? Yung area, mula sa malaki, lumiit. Yung velocity naman, mula sa mabagal, bumilis, no? So, pag kinuwenta mo sila, pareho lang, no? So, ibig sabihin, nag-balance, no? Ngayon, eto, yung velocity 1, sabi ko nga, yung velocity 1, biglang bumagal kasi bumilis yung velocity 2, no? Kaya less. Uh, Dito ka mag-refer, no? Velocity 1, yung arrow is less than velocity 2. So, velocity 2 is higher than velocity 1 if you're going to just rewrite the equation. Okay? Ngayon, ano naman ang learning natin dito? There are things that is happening in this, no? So, one of which is the so-called work or network. Let me use this, no? Total dark ang background natin. Kasi pag may energy class, na if there's an energy, you cannot separate yung work, no? Why? Because energy is the capacity or the ability to do work. Para makagawa ka ng trabaho, ng enerhiya, 'di ba? Ay, wala akong energy. O, paano ako makapagtrabaho, no? So, hindi mo mapaghiwalay. You cannot separate the two. Now, how do we compute the work or the network, no? Yung net. Calculate the work. So, sa fluid mechanics or sa thermodynamics, no? Thermodynamics, fluid mechanics, or mga power plant, makukuha mo yung work if you multiply the pressure and volume. Okay? So, ito yung work sa point 1. This is the work at point 1, and this here is the work at point 2. Okay? Now, look at this. Yung pressure times volume, no? Yung volume is constant, di ba? Kaya nga V lang eh. So, whether B1 or B2, volume, di ba? Volume flow rate is meter cube per second, meter cube per second. Kung anong nilagay mo rito, isang galon din yung lalabas. So, we don't have any issue. That's why we just put it V instead of B1 and instead of instead of B1 and V2, no? Instead of B1 and V2, V na lang kasi wala namang pagkakaiba yung dalawa, no? So, V na lang. No, we check the unit. So, unit check. Paano natin i-check? No? So, pressure, what is the um, unit for pressure in metric Newton per square meter, meaning the force acting on a certain area. No, in this case, square meter, medyo malaki, no? Sa Newton is like ilan ba yung Newton? So, halos isang 900, no? 1 Newton, mamaliit lang kasi isang kilogram force, no, is 981, no? O 980, 91 Newton, no? O kaya nga 9.81 kilonewton, no? Yan. O pag inano mo yan, maliit lang, 'di ba? Kasi i-divide mo to ng 981, divide mo to ng ano, no? 981. Yan. Ibig sabihin 1 Newton, yan. 1 kilogram divided by 9.981 or 9.81, no? So pag tinek mo yung unit, Newton per square meter, yung volume is meter cube. So ano mangyari diyan? Tanggal to, tanggal yan. So isa na lang, meter na lang, no? Newton meter. At what is Newton meter? Joule, no? Yun. So joule is a unit of work. Trabaho yan. Ibig sabihin, pag minultiply mo yung isang Newton at meron siyang distance na isang metro, ang tawag doon ay joule. Yan. Okay? So may work na involved dyan. So let us come here, no? Because malapit na ring mag-time, no? Ano bang nangyari dito sa equation na to, no? What is this equation? What is this all about? Ang pinag-uusapan dito ay yung energy, no? Ito yung network, no? Diba na-complete na natin yan? Trabaho to, trabaho. Meaning, if you want to have a network here, no, dito, ito yung point 1, ito yung point 2. para makuha mo yung work, no, sa pagitan nila, ito yon. Pressure 1 times volume, pressure 2 times volume, i-minus mo. Okay, i-minus mo. And this one, you can decompose here, no, with the two components. Ano ibig sabihin yan? mg, pag nakakita kayo ng mg class, alam nyo ba yung mg? What is mg class? Kat, ano yung mg? mgh. Ha? Ano yung mg? Alam ba yung mg? Ang formula na yan ay may kugnayan sa energy. Check ko yung... Okay, naka 100. Ang dalawang formula na yan ay potential tsaka kinetic, no? Yung energy, ito yun, di ba? Yung energy pala ay summation ng dalawang klaseng energy. Ano yun? Ito, this here is potential energy. This here is kinetic. No? Di ba pag mgh, potential yan. Potential energy yan. Pag yung isa kinetic, ito 1/2 mass times velocity squared. No? So tatandaan na, if you see this formula, this kind of notation, potential. Bakit? It has to do with ano, height. Height, 'di ba? Mg, anong mg? Weight, 'di ba? Force, 'di ba? Mass times gravity is weight, and weight is force. Yun yung humihila papunta sa Earth's center. Kaya tayo ay nakatapak sa mundo, 'di ba? Ito tayo, ito yung mundo, Earth, nandito yung tao, tsaka yung mga bagay. Bakit? Kasi hinihila tayo towards the center of the Earth, no? Mass times may gravity, which is 9.81 meter per second square. Then it is kilogram, no? Yung mass. So kung may kilogram ka, meter times divided by second square, kilogram meter divided by second square is newton, 'di ba? Tapos may h, 'di ba? So eto W is mg. Tapos may h. So yung newton, yung h is metric, newton meter, which is joule, no? Ito ay work. So joule 'yan. Okay? So ngayon, ang energy is the ability to do work. So ito nga, may trabaho dito, 'di ba? Mass times gravity is weight times height is meter. Magkakaroon ko ng newton meter. So joule 'yon, trabaho. Ito naman, 1/2 mv squared. O paano naman to? Let us check the unit. 1/2 mass is kilogram. Velocity square is meter per second. So square mo, square, no? So, kilogram meter per second square. So, kilogram, isang meter, na yung isang meter dito. Oh, i-breakdown ko. Kilogram meter times meter per second square. Right? So, kilogram meter per second square is newton. Tapos, yung distance is meter. So, newton meter is also joule. No? So, joule, kinetic, and joule na potential. Okay? Maliwanag ba? Maliwanag ba, class? Uy, sagot. Nandiyan pa ba kayo? Naintindihan ba? Hakat. Nawala yata kayo. Hello? Hello? Nadidinig ba?
Yes po.
So,
Sir,
sagot lang ha, kasi
kina-update daw po ay nawalan po ng kuryente, tapos kinapletado po. Wala
si
po
King
internet.
nawala eh. Si King tsaka si Catherine.
Opo. Si Plectado po, wala pong kuryente.
Ganon. O, sige.
Wala po
Anyway,
palang internet, tapos kina-update po pala, walang kuryente.
Sige, okay
Oras
lang.
daw po.
Matatapos naman na tayo, no? So, para lang maano. Ngayon, eto, so we were able to discuss this, no? We were able to discuss this. So, let me clear this up para ma-summarize natin. Um, Tanggalin ko muna ha para hindi masakit sa mata. So, we were saying that the network, no? Ito yung working network. Ibig sabihin mula sa point 1 papunta sa point 2. And the network is just the network is just the summation of energy. Ano yung energy? Potential and or plus kinetic. Anong formula sa potential? mgh kasi mg is weight or force, no? Tapos times height, no? Oh, work 'yun. Force times distance eh, no? Ngayon, eto 1/2 mv squared, no? Bakit? Kasi yung mass kilogram, 'di ba? Tapos velocity square meter, edi square meter 'yan, tapos second square, no? So kilogram meter per second square. So newton. Ito naman ay meter. So it is a work, no? Force times distance, which is joule, no? Yan. Okay? So maliwanag na yan. Ngayon, ito P1V plus MGA. Ina na lang, ni-rearrange lang to, no? So P1B, no, volume naman is the same. MGH1, ayun, no? Ito negative, ilagay mo doon, magiging positive. Plus 1/2 MB1, kunin mo yan. Ito, plus 1/2 MB1, ito. Negative to, ilagay mo doon. Yan. Ito naman, mga positive. MgH2, ayun yon. Then, 1/2 MV2 squared, ito yon. Yan. No? Tsaka P2V. Yung negative na to, ilagay mo doon. Basically, ang pinagsama-sama mo ay yung notation ng 1 at 2. No? Hiniwalay mo lang. All the ones, tira mo, all the ones are here. All the 2, subscript 2, no? Kasi volume to eh. Kaso, pareho lang naman yung volume, no? P2, ano to? H2, MB2. No? Pinaghiwalay mo lang. So, if you are going to manipulate this, for example, you divide by mass, everything you divide by mass, tanggal yan, by mass, tanggal to, no? P2, magkakaroon ng mass, eto tanggal. Ang mangyari dyan, ganito, ayan, no, magkakaroon ng density, di ba? Kasi connected na yung mass tsaka volume, di ba? So, eto, tinan mo, volume over mass, na para ka rin nag-divide ng volume dito. 1 yon, o mass over volume. Whatever you divide on the numerator, you also divide the same thing in the denominator, and that makes it 1, as if you did nothing, right? Because this is volume, it's like when you divide the same entity with one another, you will get 1. So, eto, magiging 1, mass over volume is density. Kaya yun, no, may density doon, or rho, di ba? Mass density. So, GH1 na-retain, 1/2 V1 squared na-retain. Ito naman, Vm is like V over V. So, 1 lang yan, mass over volume is rho. Yan. GH2, 1/2 V squared. So, ang mangyari dyan, P1 rho plus GH plus 1/2 V squared, which is going to be a constant. No? So, ang nangyari dyan, yung H, no, nawala, di ba? Tapos, eto, 1/2 V squared na lang. No? So, 1/2 V squared na lang. Okay? Kasi, kailangan mo yung ito yung simplified, okay? So yun yung yun yung tinatawag na Bernoulli's equation, no? So ngayon may isa pang bago tayo magwakas, no? Yung formula, pag kinuha mo to, ganito lang yan, no? So yung tinatawag na Bernoulli's equation, gawin kong dilaw para mas conspicuous, mas malinaw. So eto, yung Bernoulli's equation, Tatlo yan, no? So, alalahanin nyo, what you're going to remember is this, no? So, there is this pressure, no? Pressure head. Then, velocity head. Tatlo yan eh. Tsaka, elevation head. Yan. Meron pang isa, yung friction. May friction losses, no? So, pressure head, ayun no, P1, di ba? Ito, pressure head, tapos velocity head, ayun no, velocity, 1/2 V squared, tapos elevation, Z. Pag elevation, class, pag sinabing elevation, yung height, no? So, elevation head is height. So, Z. Halimbawa, Z1 minus Z2 or Z2 minus Z1. Kung mas mataas to, halimbawa, Z2. Ito, Z1. O, edi mas mataas, no? Z2 minus Z1. Then, plus friction head or friction head loss. Yan, friction, no? Frictional losses. Okay? So, yun yung bumubuo sa tinatawag na, ano, na, tag doon, ng bumubuo sa Bernoulli's equation. So maliwanag ba? What is Bernoulli's equation? Bernoulli's equation is the equation that explains or that pertains to the law of conservation of energy. Yan. So ano yung ibig sabihin? Ibig sabihin yung pressure head, no? Yun yung mabumubuo ng lahat ng head, no? Total dynamic head, no? So, pressure head, velocity head, tsaka elevation. Ibig sabihin, whatever yung nilagay mo, yun din yung mapupunta sa kabila, no? So, yun yung total dynamic head ay mababreakdown mo sa pressure, ano, ito yon, pressure over density, velocity, ito yon, 1/2 p squared, tas elevation, which is Z2 or Z1. Okay? So, yun lang. No?